program design is the first part of it. So our learning objectives for today are understanding the importance of software design, explaining the stages, and we want to analyze the stages, right? Okay, so what is the common approach to software design? Basically, students skip it, right? You don't do design, you do straight to coding, isn't it? Tak nak mengaku. Okay. So why do you do that? Right. So a lot of reasons. One, design. They think design is a waste of time. And second, they have to show something really quick. Supervisor suddenly wants to see them tomorrow, and they've not done anything yet. And you don't have time, right? Common alasan, common reason, isn't it? Okay. Well, so what is not design? So design is definitely not programming, is not modeling, not part of requirements. So when does design start and when does requirement finish? So you can actually do it parallel. You can do your requirements and design parallelly, means both at the same time, right? Okay. So what are requirements is talk about what the system is supposed to do. As design talks about how the system is supposed to be built. Okay, so what is design? So design is taking a problem and creatively transforming it into a solution. So kena kreatif. Tapi, if you want to be creative, kena bertempat lah. So you have to follow some design principle. So tak boleh just main hentam aja kan. So, right. Okay, so in our case, we want to transform your software requirement specification to implementation. So we transform it using the software design document. So our goal is to make the implementation simple and efficient. Right. So simple and efficient. Right. They have a concept called KISS, K-I-S-S. Keep it simple, stupid, right? Okay. And efficient, it has to be efficient. Means that it has to load fast, it has to respond quickly, it has to do its function. If you can write it in 50 lines of code, don't write 150 lines of code. It's going to make the program hang. Okay, so what is software design? It's the definition. It's a process of defining the software, architecture, components, modules, interfaces, and data for the system. So it's not just the modules, it's interfaces as well. Okay, we have design interface and data. So software design is so what software design? It's a bridge between your requirements and your implementation, isn't it? So among the questions that we need to ask ourselves when we do software design, how can we effectively present the design to the stakeholders? What tools and techniques can we use? We'll talk about software architecture techniques and tools after this. And what's the hardware environment? Right. So, and also not to forget, how can we include non-functional requirements in design? So these are the questions you need to ask yourself before you design. Stages of design. So you need to understand the problem, look at different angles to discover a solution, identify one or more solutions, and describe the abstractions. Okay. So describe abstractions means once you get the solution, you need to transform it graphically. Using, in this course, we will transform it using UML, right? Object-oriented design. And you may need to repeat the process again if your design is not satisfactory. Okay, then we have informal to formal design. Okay. So there are a few design stages. Okay, so there's the architect. So this is a top-down approach. So a top-down approach is you start from the high-level system, then you go down to the algorithm design or the coding, right? So talk about it here. Okay, so like design phases, architecture design, you design this, identify the subsystem, then you specify it, and you talk about the interfaces, and you decompose it, the subsystems, to more components, and then you design the data, the ERD, the class diagrams, and then finally the pseudocode, right? Algorithm design. For example, you're planning to do, you have a case study of a clinical information system. So, step 1, architectural design. First, identify what are the subsystems in your clinical information system, because clinical information system is a very huge system. You have admins, you have doctors, you have nurses, you have pharmacists, you have lab technicians. So, you have x-rays, you have a lot of clinical equipment to do. Okay, then you specify your subsystem. So what would your system do? Right. Right. After that, you need to describe your interface. So what are the inputs? What are the outputs? How is the interface supposed to be like? Who are your users? So are your users kids? Are your users mature, or are they old people? So how are you going, or are they disabled people? They may be handicapped people. Let's say you're doing a system for a telemedicine system for patients with physiotherapy patients, so they are physically handicapped. So you need to design your interface according to the requirements, right? Then is your component design. So you need to specify the how many software files you're going to do, how many Java files you need, right? How and what hardware is required. Then would be the data structure design. So that would be your ERD, class diagram, your data dictionaries, and finally would be your algorithm design, which is your pseudocode. Right? So for your SDD project, your pseudocode is enough. You don't need real code. You can if you want bonus marks, right? Right. So from requirements to architecture. So once you identify your problem, okay, and then you want to do design, you need to consider a few things, like what is your schedule, what is your budget. You may have a long schedule. The customer may say, okay, you take your time to do this, I don't need urgently, but they have a very budget chiput. So even though you have a long schedule, but because budget not enough, you have to trim, throw a lot of functions out, just the main ones. because programming takes time, and time is money. You have to pay programmers. And okay, then we talk about cost versus robustness. So the more robust your software, the higher the cost, right? Because the more functionalities you'd have to incorporate. Fault tolerant versus size. Okay. So what is your fault tolerance specification for your software? Certain percentage, maybe a few percent, because the larger your software, the larger the size, the more codes, the more modules you have, the more lines of code you have, the higher the faults that you would find. It's common, right? Then security versus speed. So a very secure software have you may have a trade-off of speed because there are too many functions. I mean, there are many non-functional requirements like security requirements you put in there, which may make the software to lag or hang. Okay. So there are the trade-offs you need to consider, right?
Right.
Okay, so where do we finish requirements and start design? So basically, you know, we can do it parallelly while we're doing our requirements. Also, we can start doing design, but that's if you have a small programming team. But you have a large programming team, you're in a large organization, you will need to finish your design before you hand over it to the implementation department, right? So what are the advantages of having this software design? So it's good for stakeholder communication, right? So rather than giving them the requirements document which has lots of words, you can communicate with them using the design. And then good for system analysis, right? And large scale reuse. So means the architecture may be reusable across a range of systems, or you may use the same architecture and give it to a different implementation team, and they will be able to implement it differently but with the same architecture, using the same design documents. Okay, so architecture and system characteristics. So basically, when we design, we want to achieve good performance, security, safety. The software must be reliable, must be secure. Availability also must be available all the time. No the crash failure hang. It's easy to maintain. Future programmers can maintain it easily. So yeah, and also it's of good quality, right? So that's the end of the lecture. So hope you understand the importance of software design. We can explain the stages and also analyze the design stages. Thank you.